Factored finite state machines break complex finite state machines into smaller interacting FSMs. So this allows us to reduce the complexity of the FSM. And when we can reduce complexity, we can simplify the design, the testing, the debugging. And so a lot of advantages there. So an example is, let's suppose we want to modify the traffic light controller that we built earlier to have a parade mode. So we're going to have two more inputs, P and R. When P equals 1, it enters parade mode, and Bravado Boulevard stays green because there's going to be a parade going down Bravado Boulevard. And when R equals 1, it's going to leave parade mode and go back into its regular operating mode. So we could have an unfactored FSM where we just include all of those features now in an updated FSM that includes all of that complexity. Or we could basically use our original FSM, the lights FSM, and add a second FSM called the mode FSM that determines when the lights FSM stays with Bravado Boulevard being green. And so in that way, we need an internal signal here, the M, the mode signal to tell the lights FSM which mode it's in. And so we still have, essentially our lights FSM will be very close to the same with an added input. And now we have this mode FSM that takes in these two new inputs and determines which mode it should be in. So here's an unfactored version of the FSM where we include all of the features in the finite state machine. But our factored FSM is much cleaner. So here we have our mode FSM, and as long as parade mode is low, it stays in the S0 state with mode, this M output being 0. But when the parade input asserts, then we go to S1, or the FSM goes to S1, and mode becomes 1. And so now, when the lights FSM is in the S2 state, if mode is true or TB is true, right? It used to just be when TB is true, stay in S2, when TB is false, go to S3. But now it says when TB is true, or if we get this M output from the mode FSM, so when M equals 1, then it stays in that state, in the S2 state, and keeps LB green and LA stays red. So it lets the parade go down Bravado Boulevard. And then now we need to have the other case include the mode case as well. So remember, we want the opposite of M or TB. So M or TB, all of that bar is the same as M bar and TB bar. So we could have written this, maybe more clearly to say that these are, disjoint cases, and they cover all the cases. That's the other case when M or TB, when they're both 0, in other words, M or TB, that is 0, that expression, that OR expression is 0, then we want to go here. Or in other words, when M is 0 and TB is 0, then we want to leave that state and start to make LA green. And so in this case, much simpler, right? Much simpler FSMs and much simpler to design, test, and debug.